The efficiency of a coal or gas furnace is relatively low when the door remains open. So the door must be automated for opening and closing in order to ensure better performance and improved efficiency. Hello everyone, I am Akram Khan, a BTech student in the Department of Electrical Engineering, Aligarh Muslim University, Aligarh. I am going to demonstrate automatic furnace door controller. This training project is developed in the newly established Industrial Automation Lab in the Department of Electrical Engineering AMU, and it is sponsored under TCube2 by the Ministry of Human Resource and Development, Government of India, National Project Implementation Unit and the World Bank. The technical guidance is provided by the ZMS Technology, Germany. So here we can see the project overview. Talking about the real world problem where the requirement is to control the furnace door automatically. Earlier, this process was done manually, a very inefficient and unsafe procedure. The process should be automated so that the furnace operates with improved efficiency and the improved safety. For improved efficiency, the gate of the furnace should be closed automatically after 6 seconds or before that manually. If the light barrier is disrupted, the closing of the gate is stopped at once, ensuring a safer operation. At any point of time, the opening and closing of the gate could be terminated using a stop button. Now let us take a look at the automation concept. This is the 3-phase power supply which is energizing the gate drive through the opening and closing gate in control. In order to open or close the gate, these are the open and close buttons. Then we have a position sensor installed at the final open and fully closed position. The light barrier is also installed so as to stop the closing of the gate at once if any personal or object comes in between. As soon as the light barrier is removed, the closing of the door is continued. We are also having a Zenitza power quality analyzer in order to prevent the electrical system being damaged from poor power quality such as overvoltage. Next, we have our programmable logic controller. All the digital signals are connected to the PLC via hard wiring. For monitoring and control, PLC is connected to visualization system which may be either HMI or remotely via SCADA system. In our case, it is Siemens touch panel. Basically, PLC receives a digital signal from the sensor and it generates an actuating signal for the operation of the motor according to the logic. The project engineering is divided into 2 parts. The first part involves the programming of the PLC using Siemens totally integrated automation software. Second part is about the development of suitable screens for overall visualization of the system using Siemens WinCC Flexible. Before we proceed further, let's get familiar with the hardware used. This is our PLC and these are the different components. This is our HMI, that is TP177B. Now let's have an insight to the programming part. You can see our CPU as a Siemens 314 C2P and DP from the catalog. It is the provident interface. This is the main block where programming is done. The language used is functional block diagram, that is FBD. The entire main block is divided into 7 networks, including 1 network in the function. The subsequent networks are: since the limited time does not allow us to explain the whole logic involved in the programming, so we simply download it to the PLC and demonstrate the live working. Now coming to the visualization part, we are having 2 screens, the start screen and the process screen. These are the tags that we have defined for depicting the ongoing process. The acquisition cycle is kept as 1 second. There is a logical connection between PLC and HMI, and these are the IP addresses for PLC and HMI devices. This is the start screen giving you a brief overview about the project and the project author. This is the main screen and shows open, close and emergency stop options. Now let's download it to the HMI to have a standalone operation of PLC and HMI. So we are now ready to see the live working of the project. This is the home screen which shows the various details of the project. Department of Electrical Engineering Industrial Automation Lab, AMU Aligarh. This is the logo of Aligarh Muslim University. the project, furnace door control, and the name of the author. Now we move on to the process screen. This is the process screen and these are the various buttons. The open button initiates the opening of the door. The close button closes the door and it is the emergency stop button which terminates the operation. Now we press the open button, the door starts to open. As soon as we press the emergency stop button, the process is terminated and the opening of the door is stopped. When we release the stop button, the door is finally opened. Now the sensor, position sensor is activated and the door will close automatically in 6 seconds. If an object comes in between, the door stops, indicated by the barrier. As soon as the object is removed, the door starts to close again and it is finally closed. When we press the open button, the door starts to open. When it has reached the final position, a position sensor is activated, and if we press the close button before 6 seconds, the door starts to close and it is finally closed and position sensor of closing is activated. This was a live demonstration of my project. Since improvement is a never-ending exercise, there are a few steps that can be further implemented to make the project more advanced. For example, live model for the automatic furnace door. So, this was all about the automation in the furnace door. I would like to extend my gratitude to the Department of Electrical Engineering, Aligarh Muslim University, to provide an excellent automation lab. I also express my heartfelt thanks to ZMS Technology for immense technical and moral support. I would also like to thank my co-trainers, technical and non-technical staff of the department, my batchmates and my parents for supporting me at every step of my life. Thank you, and don't forget to watch other videos.